Okay, so here we are for our part two of Java generics. And in part one, we open the code here. We implemented a multi-type generic pair where K represents the key type and V represents the value type. We included methods to get and set the key and value, as well as to string methods to print the key value pair. And we developed a generic stack class that allows pushing and popping elements of any type. We implemented methods for push, pop, and checking if the stack is empty, and ensuring that the stack gracefully handles underflow when popping an empty stack by throwing an appropriate exception. Uh, I do not touch on this actually, so I'll try to go over this um, in this demonstration. Moving on to part two, we wrote a static uh, generic method, right? So a generic method sorts in a utility class that sorts an array list where T extends comparable, right? And then we wrote a method print collection that accepts a collection and prints each item in the collection. Yeah, so prints each item in the collection. And so and then hold on, let me so then extended this by writing a method sum of number list that accepts a list and it extends number and it returns the sum of the elements. For our part three, we designed and implemented a cache class that can store instances of type T, and the cache should have methods to add items, retrieve items by key, and clear the cache, and utilize bounded wildcards to implement a method at all. Yeah, adjust this a little bit here. I do also have to apologize here for the sound quality on the past two videos. Um, using here some noise, isolate some voice isolation features here. A little bit unfortunately in a noisy place, but I've done my very best here to be clear. And so, yeah, so we implemented a method at all that can add all items from one cache to another, provided they are of compatible types. Okay, and then we, of course, created our main to interact, right, with our methods. All right, so let's go ahead and show the program's functionality. Right? So let's go ahead and run this. And so here we have, right? What we're reading here, we're reading the key and value pairs age 23. All right, so age key 23 value we have right over here. Um, and we have as well, let me, let me write this in the line real quick here, just because. So we have here the, so we have here this stack, right? Called this in stack. And we pushed integer 2, integer 34, we pushed integer 26. And so then we ran, we print uh, the int stack and we popped. Right? Remember that pop in the stack, I believe, where the stack class. So popping the stack from the stack class removes the last, right? The last element of the stack. And so let me probably point this out. Where is it again? Let me point this out. It usually is if you have Java version, mean, I think it's, I'm not quite sure, but I think Java version 21. Um, and if you have anything lower than that, um, you should probably do something like this. You should return. You should, how does it work? I think you should return, I think it's something like this, right? Remove, something like this. Right? So the stack, okay, actually, yeah, you should remove stack, stack, remove. I could be wrong, to be honest. Figure out how to do this, but it's something. Yeah, like if you remove, hold on, let me uncomment this to make sure, because I don't want to have to. You guys, yeah. So it should be so. Yeah, and let me just make sure I'm not. Yeah, okay, that's great. Yeah, so if you have anything lower than probably 21 on Java, the version, running this essentially negative. This -1 or -1. What it does is it collects, it pulls whatever you can have a list of a billion or a million, elements. As long as you have here to always pull the last, right? To always pull the last element. So uh, say version, version of, okay, let's uncomment that. Okay, so but anyways, going back to it, right? So here we have 26 because we are printing out, we are printing out our last element here, 26, right? And we confirmed this in part one of our video of our generics too. And I want to let me let me print out the instack itself as well. Um, to the print line. Yeah, let me do um, something like that. I can show you that. Let me save this line, yeah, and just write it over here. Okay, so that's a better plan. Let me go back to explain line here. All right, so what we are having here, this is a stack. I'm trying to figure this out here. So what this is giving us, this is correct, but it's giving us the address. It's not giving us what we wanted to print out, right? And I think this is because we need a two string. So we need a two string. Let me identify where we need this two string here. Identify. So what we're doing here is stack in the stack class, and we are trying to print. So we need to print. Okay, you go to the stack class here. Maybe part. All right, let me do a override here to the public string to string. Again, override because it's part of the Java object class. So it just defines the content or the characteristics or something. Without the explanation for that. But yeah, so we're gonna return. Mm, let's see what we're gonna return. What should I say? We're gonna return. Wait, what do we need here again? I forgot. So we need the. Okay, so we have a pair. No, sorry. We have a integer. Uh-huh, uh-huh. And then in the stack class, what are we passing? To try to figure out do something real quick here. All right, so any type, right? Uh, so um, hold on, trying to figure out things out here. Hold on, give me a second here. Let me say, I don't know. Let me just say contains. I'm not sure. Just say contains. Um, Okay, so we have contain. That means we need the item. No, the item is okay. The element. So we need the stack itself, right? We need the stack. Okay, so we get here two. All right, so we're gonna say array list, right? Or stack list. I don't know. Yeah, stack list. Right? All right, so stack list contains and what else should I say? Should I fix? I mean, I could want to. All right, so let me okay, mention it. Okay. So stack list contains plus the stack. And then so that contains. So then, as we can see here, right, it originally contained 2, 34, and 26, and then we popped 26. And so let me now, let me print that again. Right? Let me print that again to confirm. And we need some space in that. Um, how can I do this? Okay, let's some space in there. Um, hmm, okay, so that we have so we have a bug here. Try to fix this real quick here. And I think I lit line. So that it's okay, I do a linear line there each settings a piece of like uh let me do the line there, that's that. Uh let me go ahead and also fix your safety. Let me so here. Okay, inside the fingers. We are just, again, embellishing here, the UI. We just want to improve our looks here. Nothing special here, to be honest. It's but let me, yeah, that's good. So the stack list contains this stack list here. Where's the stack list? Stack list, please. Where's the stack? Let me do that on a line. Okay. And then what else we so we just, fixing how we want our program to the visualization of our program essentially, right? And this is what we're doing, right? Showing our program's functionality, how we want it to be presented, right? All right, so this is somewhat better. We have a key, age, all right? So let me say, okay, this is somewhat enough. All right, so we have a key, age, value 23, stack list contains 2, 3, 34, and 26. And after 26 got popped out, we got stack list contains only 2 and 34. Okay. And okay, let's go ahead and see our array list. So this is our array list, integers from generic utility sort numbers, right? Well, we already wrote the numbers sorted, so let's unsort this real quickly. Let's write here one over here and five over here. All right, so we have 1, 3, and then like 2 over here, right? So let's go ahead and see if we're gonna have a sorted list of 1, 2, 3, 4, uh, 5, we don't have 6 on the right, 6 right over here, 6, 7. And it's okay if we are missing numbers here. We essentially know that after 7 comes 8, and if not 8, 9. Um, you know what? Let's do this. It's an old joke, right? Where is 9? Oh, 7, 8, 9. I don't know. It's weird. I just wanted to bring up this joke. Oh my goodness. And so let's go ahead and run this. Okay, so we have um hold on. What do I do? What do I do? I want to yeah, so we have a 1, 2, 3, 4, 5, 6, 7, 8. That is correct. And then we have as well our array list in our collection utility. Claude. I actually wrote this Claude here just a couple moments ago. Alexa, Bard, Cortana. And so we have here Alexa, Claude, Alexa, Claude, Bard, Cortana. And what else? Let me actually fix this as well in the collection utility. Um, I think this is really unnecessary to be honest, but I'll just do this. And let me just do this instead. Let's see. So let's go ahead and see the difference, right? Okay, so here we have a much better, I believe, organized. So we have your Claude, Alexa, Bard, and Cortana. Okay. We can as well say something like um, collection list or something. I don't know. Alright, so collection list. Uh, okay. So here we have Psalm 6.9. This is a sum of these doubles here. We have some of the doubles. I should probably, let me see if I should do a system print line. We have a dub numbers here. Go ahead and print that as well. Um, Let me say, um, we should say something like number seven. Okay, so we have that figured out. Not pressure. Okay, and so now let's go ahead and test. There's something here that I remember highlighting. Oh yeah, yeah. So ensuring, what is this? Ensuring that the stack gracefully handles underflow when popping an empty stack. Oh, okay, yeah. So when popping an empty stack, where were we? So we're here, right? Uh, so let me go ahead and copy these two lines here. Okay, so we essentially popped 26. That means we in our int stack, right? We only have the element 2 and element 34. And we can confirm that by running this one more time. Yeah. Oops, what do we have here? Oh, should be uh, no difference. Oh, no, that happens. Okay, let me look it right here. Okay, so where was I? What was my explanation right now? Okay, so we first have our stack list contains 2, 3, 34, 26, and then after we pop 26, we have 2 and 34 left. And then when we pop again, let's see what we have here. We're gonna have one less element, I believe. And so that is correct. We have 2, and then we're gonna pop again, and then we're gonna have an empty um, stack, right? We're gonna have an empty stack. So now what happens? I think yeah. So the instruction is so we want to ensure that the stack gracefully handles underflow when popping an empty stack. So we have an empty stack and we want to by throwing an appropriate exception. Yeah, I don't know what exception it's going to throw, so we're going to have to test this ourselves. Let's see this one more time. Um, Let me go ahead and remove this to avoid any confusion. Okay, so we have here no such element exception. So this is what we get thrown here early. So we get a no such element, let me memorize that. No such element exception. Okay. So that's the appropriate, so that's by throwing an appropriate exception. So that's the exception that we get when we try to pop an empty stack. And so let me try and fix this by, let me see here. What we can do is we can catch, right? I think the question is how do we catch? Let me see. All right, so we can catch this. What is catch? Catch is uh, an operation, I'd say. It's an operation that helps to avoid your program from crashing, right? Uh, some exceptions propagate the program and then causes it just stop abruptly. And that could be done by, let's go to our stack. So popping, right? Okay, let me do, let me have this over here to start doing a little bit. I'm not going all the way. These are really tough. Uh, so what was the what was it called again? No such element exception. Okay, so let's do an if and say so if the stack uh, is empty, the stack is empty, we're gonna throw a new uh no such. So what it was? No such elements. I think that's what it was. No such elements exception, right? And yeah, and so we can catch into this. Yeah, simple check it out. Mm, what to do, what to do. Um, cut this out here. Angle time, so to try and paste this in. Okay. Uh, so we're gonna try this, right? And assuming we get the exception within these how does it within this block, right? Within that block. And so we know that we're gonna get an exception, right? So we throw the line of code that creates these errors, and we kind of like throw it in a shell of sorts, I guess, like a security. I don't want to say jail, but so we throw it in a shell, and we know that something. We try to squeeze it essentially, right? Imagine you're trying to squeeze, and you know that something is gonna try and escape, and we try to catch whatever it is that's gonna escape, and we write a catch, right? So we know what's the name of that error again? So we catch this error because we know that every time we try to run that, we get this no such element exception. Uh, then we save it. And you can shorten this with usually everybody writes E for error or M for message, um, or whatever you want type of variable you want to store it in. It's just to help you in case you need to test something out. And, and you can do a system uh, dot print line, right? And we can say stack P's and T's. Let me do like a cool representation. Um, yeah, and so this helps to try helps us to save write the code and catch the exception without propagating the program or and in that way avoiding the program from crashing. Okay, so let's go ahead and run this again, see what we get here. And so here we got stack is empty, right? No syntax errors. Everything seems good so far. Yeah, so we did here. There's a stack again. Yeah, okay. Yeah, it looks good. And your program might give you a different error. You try that line, you catch it, you print it, you let the system print it out. And yeah, in some cases, you might also receive like two errors, right? Let's try to, let's figure out the amount of this. That's a lot of students. Maybe studies on time. There's a stack list contains two now. That means we need 20, we need 34, right? Um, say pops, 20, uh, what is that? 34, so sorry, 34, and this pops 26. So let's go ahead and pop two, pops two, which leaves the stack empty. And let's pop the, the empty stack one more time. Confirm we're catching the error properly. Yeah, and then so we're catching it here. So stack is empty. Yeah. So let me try to run one more. I don't know. Let's see if we get some kind of error. Nope, we don't get. So it successfully holds. Oh, sorry for that. So we successfully hold uh the the error, right? And so our exception that we're getting is the no such element exception. Right, so I can go ahead and remove this line. Don't need that. Let me also just reduce here the amount of lines here. I feel like I can reduce some lines here to just, some one-liners, saving some line space, I guess. Okay, I'll just leave this one in there. Let me see what else here. Yeah, this can definitely come here. Java doesn't really care about how you organize your code in the block, as long as you have your proper syntax. Okay. Well, this one as well. You don't have to do this really. It depends. Of course, this way here has a better readability. It's for better uh, readability. So yeah, I'm just trying to reduce the number of lines here in this program. Oh, maybe. Okay. Uh, there were a lot of lines here. You could literally see some cool lines here. Here, here. Okay, okay, okay. So, so far so good. No syntax errors. The class is compiled. So let's go ahead and run this and properly now this time show our program's functionality. Right? Finally. Okay, so here we have our key age value 23, stack list contains 2, 34, 26. And then we popped 26, then we popped 34, then we popped 2, and now the set is empty. Uh, this is the numbers list here that got sorted. We have our collection list, Claude, Alexa, Bard, Cortana, numbers. These are double, double data, right? Numbers. So numbers of type double, of data type double. Sorry, numbers of data type double. 1.2, 2.3, 3.4, and the sum of these is 6.9, and we have yes here. Okay, so let's go ahead and um, present test cases, right? Really the basic stuff. And my code will be available in my GitHub. Let's go ahead and test. Ooh. Oh, okay, what do we have here? Unexpected exception, type cloud, empty stack exception, but was no such element exception. Oh, okay. Uh, you know what? So let's go ahead and change. Let me change these exception here. I think I remember why when I was doing these unit tests, I got a different exception when I did the unit test. I remember. So let's go ahead and change here. Let's sketch instead. Oh, actually no. Hold on. Let's catch the expected exception, which is empty stack exception. So empty stack exception, and let's throw is here as well. Okay, 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 okay. Let's see what we get here. Okay, anything here. Um, okay, so as well, no syntax errors, and it gracefully handles the error, right? It gracefully handles the underflow. Uh, so it gracefully handles the exception. Okay, and let's run again our test case. Okay, so we successfully passed all our test cases here.